Good Sunday evening, everybody. Oh, it's been a day. As most of you are well aware by now, my original stream that was supposed to happen tonight was going to be a collaboration with myself and the first layer. Richard Cleveland was going to be here, but unfortunately, there were some certain events today that just prevented Richard from being able to make it. So I had to make a last-minute change, almost a last-second change to basically, we're postponing that stream. That will happen possibly next weekend. We're going to be discussing it in the next day or so. And so instead tonight, I'm going to continue on with the 3018 PROVer router and go ahead with that. So and I just want to say hello to everybody in chat. I know there's about 13 people watching. And I assume that everybody that's here is aware of the postponement because of the description in the video and because the original video was taken down to just today and the new one put up. So it happens, right? So welcome to the world of live streaming. Circumstances happen, life happens, and we just got to roll with the punches. So we're just going to continue on with what we started last week, which was the build of this little router. And we're going to continue on. And I have a special guest with me tonight who's going to sort of hold my hand, walk me through, give me some advice because he knows a little bit more about this than I do. I've been doing some video watching and reading this week on it. I'm pretty confident I'll be able to get something engraved on this thing tonight. So let me bring in the one and the only Liam, Astro Printer. You guys all know him. Liam, how are you?
Howdy.
How's it going?
Good, and you?
Oh, I can't complain. It's been a hectic Sunday with a last-minute change, but hey, we roll with what we have, right?
It happens, right?
It does.
We've all canceled stuff, like the streams, especially last minute, because someone can't turn up. But
yeah,
you settled for me.
and it's all no, I didn't settle. It's all you were the plan all along. It's just it wasn't planned for today. So, but that's okay. So
yep.
So I've got. This could end in tears. Yeah, I know it could, Kieran, especially with you on the stream. I'm going to try and keep an eye on the stream as well. What's to say? Richard's check bounce from Tim, so he canceled. Yeah, there we go. That's Jerry. You're not supposed to make that public. So I got this at this point, and what I've done, I'll switch to the other camera. The only thing I've done differently through the week that I didn't feel was necessary to do live is I put I just sort of did a little bit of cable management, put the looms, I guess they're wire looms, whatever you call it, over the wires, cleaned up the wiring a bit so that there's not so much mess in the back here. I plugged in the little offline controller.
You'll need that.
Yes, and I haven't done much with it yet. And actually during the week, I had ordered these and I didn't expect them to be in for another week or so, but I got these, I think they're called spoiler boards.
Yeah, you can damage them. They're only really used when you're doing cut throughs. So if you're just cutting out a design in a board, yeah, that's fine. If you want to cut through, so what's left over can be removed.
Yeah.
Then the spoiler board is designed to be cut into, and eventually when you get so bad, you dump it and you put on a new one.
And you put it, yeah, because I don't recall ordering two, but I got two in two separate packages. I think they might have double shipped me.
Well, that's only if it's only if you do cut throughs. If you're only doing surface engraving, or if you're doing like 3-dimensional, but you're not going through the full thickness, right? Then they're really not required.
Well, I do plan, and the reason I looked at these is because I do plan on cutting some acrylic straight through. So this may come in handy eventually.
Yeah, when you're doing cut throughs, just remember to leave tabs on the cut throughs. You can cut most away, and you leave a little tab, maybe 2 or 3 of them, so that way then you cut them off and send them down later on. Because if you don't do that, when you cut through the last piece, the part you're cutting will move and it'll impact the end mill and end up getting damaged. So.
Okay, makes sense. And you were telling me offline, and I looked, and yeah, it is what they have on this little SD card is they have Gerbil Candle.
Yeah, Candle is free, and it's a slicing software. Yeah. Well, basically a slicing software, toolpathing software for it's a control software for your CNC, right?
Okay.
You can use easel which is free from instructables.
Right.
You can use easel to create your toolpaths. I use Fusion 360. I think it makes better toolpaths, so I use Fusion 360.
So if I just want to cut lettering into a piece of wood, if I want to just cut it in, I mean, I could use my laser engraver, yes, but if I wanted to use this, and then so what would I use to create that design?
You create design in something like easel.
Okay.
And then you'd use what's it called, the Gerbil software to actually run the machine.
Okay.
Now,
so
you don't have to though, because you have the offline controller, so you could actually create the file on the offline controller and play it from there, and that will do the same job.
Well, I understand. So could I use Illustrator, say, and just keep it as a vector, as a path file, and you know what I mean?
You'd have to take the path file in through a software to create the toolpaths.
The toolpath to put on this.
Yeah, because toolpaths has multiple aspects. Okay, so it's not only X, Y, Z coordinates. It's about how deep you go, and it's about speed. It's like a 3D printer. It's like using like Cura or something like that. So you need to create the path, and then, like, if you're doing a part where you have to clear out a lot of areas, like it's a lot of detail, then what you do in that case was, you don't have the bits for it right now, but you do what's called a rough cut, which uses a larger end mill that cuts out and clears out the area.
Okay.
And then you use a finer bit to actually fine tune, like a 1 mil ball end mill or something like that, to actually fine tune the finish, because a rough cut will do different paths, but when you're doing the fine detail, you're going to go over and back like a printer would, an ordinary like a desk printer. It goes over and back on the print head, but you're doing that at tiny little steps, but it does it in X, Y, and Z movements as it goes, to clean out the last of the material to give you your finest product.
Okay, and Shane says, so you can create your design in Illustrator, then take your SVG over to a program like ESTL. Okay, so create it in Illustrator, but then take it to something that's going to create the cut paths.
Into easel. Easel will do the cut path for you. Or Fusion will do the cutting path for you, but you have to create in Fusion, it has to be a 3-dimensional model.
Right.
To be able to, so it knows how deep to cut.
That makes sense.
Yeah.
So I also got, and so I think what you're talking about, because when I got the boards, it was suggested I get a bit similar to this.
Okay, that's a leveling. That's for leveling the sacrificial board. Yeah. So you put the board in and you clamp it down, and then you set up basically you mill out the whole size of the board, or a little bit bigger than the board. You mill it out, and what that does is it makes it perfectly level,
perfectly flat,
with the parallel to the cutting tool.
Okay, so it's sort of like leveling a 3D printing bed in a sense.
Kind of. You're cutting away the non-required material to make sure it's level on both sides, because those boards are going to be slightly thicker on one end than the other. Yeah, that brings them in line.
And then they got a few different bits.
So they're a little out of focus, but the end one looks like a 3 mil flat end mill.
Yeah.
The next one,
it's hard to focus on here. Actually, if I were to go to this camera, they're probably easier to see here.
Okay, yeah. So the first one is a flat end mill, the one on the right hand side. The second is a ball. The third is a ball. The fourth is a flat. So you have a mixture of flat and ball end mills.
Okay, cool.
Yeah.
Yeah, it's like a variety pack here.
So I would use the flat end mills to do a clearing out of an area. Okay. And then, depending on how detailed your final product is, you always leave about 0.5 of a millimeter left behind, and then you use ball end mills to do fine detail, and then you use the V-shaped ones, which are the V-carve ones, for carving intricate detail.
Oh, okay. Okay, cool. Very cool. What's old curmudgeon saying here? And Lama, let's see what Lama's saying here. He's saying you can't. Let's see here. You can't cut SVGs with the 3D info. Fusion will carve or trace depending on the settings you select. Okay. Yeah. It makes sense when you're 3D, because you're going to carve 3D or trace. Yeah,
you have to bring the SVG into a product that will turn it into toolpaths.
Yeah.
Which is what which is what easel will do for you.
Right. So the other thing I had to do, because I wasn't prepared to do this today, is I was going to bring I have some wood pieces and stuff at my office. So I ended up I have a small, tiny little cutting board that I actually bought for laser engraving on. I needed to find something that would fit on the surface of this just to test it on. So I got this guy, I got these two little pieces that came with the laser engraver, and I've got a tiny little acrylic piece.
Well, the acrylic you can do, the thin pieces, 3 mil pieces, you probably won't do much with them. They're too thin.
No. I got a larger cutting board, but that's a little too big to be.
Yeah, but you don't have to engrave the whole thing. And those engravings, just remember, they take time, right?
Yeah.
Because, like, on average, with a 3018, you'll be going down 0.5 millimeter per path.
Right.
And if you want to go deeper, you do another path, another 0.5 millimeter down. Then the next path, maybe drop a 0.5 millimeter, and you repeat that process. So
okay. So I got this all set up now, and I think I'm at the point where I need to. I guess I don't know where the next step is to go from here.
If everything's set up, have you powered it on and make sure it works?
No, and I guess that's what I should do.
So what you need to do, make sure there's no end mill in it, first of all.
Yeah, there's no mill in it at all.
Okay, so power it up, and using the hand controller, we'll make sure it moves.
Let me plug this in. Okay, and I'm pretty sure I got power to this. I do.
Yeah, we're not going to do it big. They are messy, which is why you have to have an enclosure.
Yes. Oh, speaking of the enclosure.
Yes.
I did build this. I was bored yesterday, so that little thing I didn't know what it was, I threw this together. And this is a perfect fit.
Correct. Yeah. So it doesn't help with noise, but it'll keep most of the dust out, and it will actually keep it tidy. But what you will have to do is regularly, while it's working, get a vacuum cleaner and vacuum up the material as it cuts. Otherwise,
it'll get out of control.
Yeah.
And it's funny, it came with these pieces. I don't know if you can see them. They're clear. They're almost like corner pieces.
Okay. Is there a lid for it?
But there's nothing. There's a lid. Well, the lid on it. There's nothing in the instructions about these pieces. I looked carefully. They're not even on the parts list. So how this thing went together, if you can see the front of it here, let's see, let me move this out of the way. Okay, so this just sits like this, and then the lid is a simple single piece with no hinges, but it's got magnets.
Yeah.
The lid just sticks on here, right there with magnets. That's it. So I just think it's funny that they threw these in, and I went online and looked, there's nowhere.
They're probably trimmed for around the door so you can take it off.
Or something, I suppose. But
I'm guessing they're trimmed for around that. So then you clip them on, and then it sticks on with a magnet, but you can actually just pick it off as you need to.
I suppose so. Anyways, I didn't play around with it too much.
Yeah, but that's probably what they're for. That's what it looks like.
Yeah. I just found it funny. They weren't on their parts list at all.
Yeah.
It's almost like somebody said, we'll just throw these in for them, but we won't tell them what they're for. So. Okay, let me pull this up.
So normally there's two ways of doing cutting on this, right? Mm-hmm. One is to use the metal clamps it comes with to actually slide into the extrusion on the cutting bed.
Yeah.
And the other is what some people do is they get painter's tape or something like that.
Yeah.
And they tape the underside of the part. And then they tape the bed.
Oh, yes, okay.
And they put the super glue on one side and the reactor on the other side. And they push them together and they glue it together, and it never moves. So you don't need clamps. That way, then when you're doing cutting that's very close to the edge, the clamps don't get in your way.
Oh, I should try that. Because I do have all these metal clamp pieces that
we'll use the clamps for now for an initial test, right?
Yeah, but I've got
test pieces that came with it as well, was there? Like a piece of wood or whatever?
No, it didn't come with any wood.
Oh, normally comes with little samples, maybe 100 millimeters or 50 millimeter square.
That's why I had to scramble to grab this cutting board, which should work.
Well,
I mean,
yeah,
it
the
would.
sample files. There's a few sample files that normally come with them. And I don't have the SainSmart. I have the R2, but they're pretty much the same. And
Yeah.
the sample files are .nc files that are
Oh,
should
okay.
be on the USB stick that came with it.
Yeah, I believe there are. Let me just have a peek.
One
here.
that probably says SainSmart and it engraves the name with a V carve.
Yeah. Yeah.
The other is the SainSmart logo, I believe, which is the icon.
Yeah. So this one. Oops. Bear with me 1 second here.
Sure.
Man, when you have 3 monitors going, the mouse can get lost real easy.
Hey, Justin. Hey, guys. Since you're busy, I'm going to say hi to everybody.
Oh, that's fine. I'm not really paying a lot of attention to chat today. And anybody who is here, just if you were expecting the CR30 build, that's going to happen another day. We had to have a cancellation today, so kind of had to just come up with something new to do. So we're just continuing on with this router. So if I share this screen, and this and make this bigger. So yeah, the ones that came with are, I believe.
Well, you need to install a driver first of all, right?
I installed a driver.
Okay,
it was
good.
something to do with Windows. Yeah.
Yeah. The driver is your controller to talk to. It is a USB serial controller.
Oh, okay. Yeah, this has a file called O, and then a file called SainSmart, and then a file called Wheel.
Well, the SainSmart is a text. I'm not sure what. The wheel is actually a logo of a cog of a wheel.
Oh, okay.
So if you wanted, and that like the SainSmart one is often done with the V-bit, but you can do it with any end mill. It's designed for V-bit, and it's only a line of text. That's all the SainSmart one is, I believe.
Oh, okay. Okay.
If you double click on the, if you double click on the SainSmart logo, because it looks like you got a software that'll open it. Double click.
What's it? Oh, it looks like it's going to try and open my Movavi software.
Okay.
Movavi.
Apparently something can open it. So.
Yeah, but yet it says not responding. Okay.
Okay. Did you install the software that came with it?
I do have. I did install. Let's see, where did I put it? Here, let me minimize that. Let me hide this window for now. Minimize myself, and it is. I installed Candle. Well, Candle is not really.
Well, Candle. If you load Candle, and load one of those files, you'll see what it is.
Oh, I see. Okay, so let me just go here. Let me bring myself back up so I can see what I'm doing. So now in Candle, which I've installed, or opened, it doesn't really install.
No, it doesn't. It just runs.
File opened.
Yeah.
I should be able to open one of those. So I believe it's on my desktop, and I believe it's under G code right here. There we go. So if I say open the SainSmart, there it is. Okay.
So that's the SainSmart logo, right?
Yeah. Okay.
And you can zoom in and out on that. And if you see where the square is with the like the arrow going down to the square, that's where when you're connected to your via the computer, connected to your CNC, that's where your cutting tool is.
Oh, right here, right where this. So this thing here is representing the cutting tool.
Correct.
And it's going to basically poke down here to start, and then it's going to start the cut because it shows the black is the cutting path.
Correct. Now, if you see below that, that's all the code is. That's all the toolpath code. If you look below it, that's down the code telling where the toolpath where to go.
Oh wow. Okay, so that's like got hundreds of lines of code. Okay.
Yeah, but they're small instructions. But yes.
Yeah. Okay.
So now that's the SainSmart one. Now on the SD card, on your hand controller, you can run these on your hand controller directly.
Right. Okay, well let's fire this up. Let's go to the bench camera. Let's do this.
Yeah. So let's get it working and make sure it functions and moves the right direction.
Here's the power
controller. Now, the way the hand controller works is The yellow button is your, I believe the yellow button is yours, or no, the green button is your selector. The yellow button is your OK, right?
We have power. That's a good thing.
Okay, so use your left and right arrow keys to see if you can move X left and right.
Ah, we're moving. Let me step 10 millimeters. Okay, that's moving.
Good. Go the other way. Now do the same with Y.
Okay, well, Y.
No, that's Z.
Oh, that's no.
Oh,
there's
that's Y.
Y.
Okay, okay. Mine is slightly different.
Okay.
Yeah, and then
Y is moving.
And then use a Z.
Z. There it goes.
Okay.
Okay, we got movement.
Okay, now in the menu, if you press the middle button and hold it, the menu should jump over to the left-hand configuration. Now hit the green button. Or the red button, sorry. Red button.
Oh, there we go. Then we have spindle, laser, probe, 0. Yeah.
So there's two things you need to do, right? I would say fix the part on your fix the part to go to home. There should be a home option there using the up and down keys. Or no, using the yellow key, sorry.
Whoops.
Yellow key.
Yellow key. Ah, there we go. Home. Enter. Oh, it's going to home everything.
That's what you want.
Yeah.
But you have end stops and so on. So
yeah.
You wanted to sense its home position. So it's basically parking everything, right?
Yeah.
Okay. Their end stops are working. Good.
Okay, so it's all homed.
Okay. Now, I would
go to spindle laser. Should it start the spindle going?
If you go to spindle, yeah.
Oops, wrong button. Select spindle laser. Nothing happens.
I don't know that controller, but there should be a spindle speed.
Everything's plugged. Just make sure everything's plugged in here. So the spindle.
Yeah, if you can show me the menu, I can probably help you figure it out.
Yeah. Whoops.
Okay, no, that's too bright. Okay, we don't want to 0. Go down.
So we have probe.
Yeah.
Then we have, man, that's bright, isn't it?
Yeah, it's okay. Go on probe. Go on this next.
Probe. We have 0xy and 0xyz.
And we don't want to do that. You don't want to do the reset either.
Then we have home and reset.
Okay.
Hit
the red button to go back. Hold it. Hold it for a few seconds.
Hold it. Oh, okay. There we go. Now we're back to the file control screen.
Well, I thought we could set. I'm not sure about this one. I know on mine I can set the spindle speed.
No, I read somewhere that I have to hook it up to the computer USB or something, and I have to. I just remember seeing this somewhere. I got to measure the depth of this probe and enter it in the G code. The depth of this probe.
Okay, that's because you need to do the offset of the probe.
Yes. So why don't I see if I can hook this up with USB? Let me see. I dropped my cable. I have a cable over here, but it fell. Where'd you go to?
But the probe doesn't matter. You don't have to do that for the test parts, do you? No.
Probe it for the test parts? I'm not sure.
You have to probe it for the test parts to level it.
Yeah.
But you should. But there's two ways of leveling. You can do a probe, which is electronic, and you have to do the Z offset, or you can clamp the piece of material in there, and just do a piece of paper to measure the offset. To make sure that when the cutting tool is touching the part.
Yeah, I remember seeing something about that. They put a piece of they had taped it to because you can set the it's almost like the
it's like a 3D printer. You can actually bring the cutting tool once you insert it, down to the print surface of whatever you're going to engrave,
Yeah.
and have a piece of paper underneath. And when the cutting tool is just catching it, that's home. That's your Z, and then you set it as your Z.
And I think that's what, and I'm sure that's what this guy does too.
That electronically does it, but it does it. But you need to have measure and offset. The other way, you don't.
Right. Okay. Let me first of all just see if I plug the USB in, if I get communication with this. Okay. Okay. Oh, my computer recognized something.
Yeah, because the driver's installed.
Okay, so I should then. Let's just,
if you go into what's it called? Candle.
Yes.
Okay, so go to Candle and try moving the axe. Set service. Go to service, top menu.
Oh, service settings.
And in here,
there's where it says to measure the
your Z offset.
The Z offset.
Yeah, so get a calipers and measure it and enter it there. It's the last G command, I believe it is. G38, I believe it is.
G38.
But you have to go measure that and see if it's the right size.
Okay,
I'm not sure. I think that's where you change it.
Yeah, I saw. Actually, hang on. I think I have this queued up. I think let me just do this. Oops. Let me cancel this for 1 second.
Sure.
Man, too many screens going here, but that's okay. I'm not mistaken, it was in here. And this is going to show me. Hang on.
Yeah, I believe it's just after that. I think I've seen similar videos that you do the Z probe and then you do the offset.
What the heck did I do here? Where's that video? I'm just jumping around screens here. Oh, there it is. So there, it's showing the under. It's hard to read what that command is.
Edit the commands. Yeah, it's the second last one. Okay.
Second last one. Okay.
Yeah. So, and what you do is you measure it, and then if you bring up the candle screen again, and go into the settings, the service settings. So it's there with the G38. You measure the offset and you enter it there.
Okay, so
measure the height of that with the calipers.
Okay, we're zeroed. Good.
And measure right into the center of it.
.05.
So you change the G0 to the G38 to 1405, I believe.
Now, do I get rid of the 38 altogether? No.
No, just I can barely see this. Let me move my screen over.
Yeah, that's tough. Let me make this full screen. Hang on.
Yeah.
If this makes it any better.
That and me being blind doesn't help.
Yeah, I believe.
So it's the G30, the G38.
Then there's a period.
Yeah, go back over to the video again that you had up.
Yeah.
Flick over.
Okay, bear with me 1 second.
I just want to be sure.
Let me find the spot in the video. So he
Z14. So he changed the G.
So let's go back to where there. He's going in there now.
Yeah.
That's not very clear at all what he's doing.
Well, it says Z and then a number, so you change that number.
Z14.
So okay. Go back over to yours in the candle.
So he changed that right there. Huh.
I never did it that way anyway. Here's how I do mine, right? I know the height of it.
Yeah.
Actually, bring up candle again. Sorry, full screen. It says it there already. Yeah, it says G38, and that's your probe target, right?
Yeah. G38.2. Then it has Z-2F10.
Well, there's another way of doing this. So I'll show you an easier way for now, right? Set up your probe. So you have to have your probe plugged in, and you need to put in your V-carve end mill, one of the ones that came with it.
Yeah. Okay. Let me get this screen back to where it should be.
Because this is going to vary a little bit, right? So what I do is I do a Z probe.
Yeah.
Right. I move my end mill. You can also move your end mill down, and then down the height, and then just say 0Z in candle, and that'll do it.
Oh, I see. Okay. Well, let's do that. Let's throw a.
So put in one of them because we'll do that. We can do. Let's do the SainSmart logo. It'll be
Okay.
an easy one to do, and it's just going to engrave text.
Okay. Let me move the axes over here. Let me move that 100 over. There we go. And let me move the Y forward.
Now you should have 2 wedges for because that has an ER11 collet.
Okay.
That's what it comes with, right?
And
get other collets. I have a collet set for these, so you can put larger shaft bits into it.
Okay, why is my Z not moving? Or my Y? Hang on one sec. Oops. I keep hitting the wrong way on the Y. It's kind of reverse. Y plus, they should have it downwards. My Y doesn't want to move.
Is it moving? Which direction is it moving?
It was moving the opposite of what I thought. There we go. I just had it. The up is moving it forward, which is plus.
Yeah, forward to you, positive to you is what it's doing. Yeah.
Okay, so take this off. I already put the collet in.
Okay.
During the build. Yeah,
now
so
be careful. Those end mills are sharp when you push them in. Be careful because if your hand slides in them, you'll end up briefing your finger.
Okay. What I'll do is I'll leave the safety cap on for now.
Yeah.
And do I push it up all the way or just
push it up and screw it and push up as far as it'll go? Because when it's putting downward pressure, you want resistance at the top.
Okay, there we go. Whoa, that is sharp.
Yeah, told you.
And the wrench, yeah. Hang on, let's see. Did I? No, it didn't get any blood. Sorry, guys.
So much for ratings.
Yeah, no kidding. Okay, and then we will tighten it up. Whoa, come on. I'm at a weird angle just so the camera can get it.
So Lama says, cut your damn fingers like a man.
There we go. Okay. So now we need to put the Z probe on, right?
No, you need to fix your part to the bed. So you should have 2 little brackets that are like flat plates, and they should have a screw in one side and thumb screws in the other, and they should go into the V slots there.
So these guys.
Yeah. Now, so what happens is the thumb screw goes near the part in the long slot, and the screw goes in the single hole, right? And the idea of it is the screw lifts up the back.
Yeah.
Right, and then the thumb screw pulls down onto your part.
But doesn't something, because I got these T-nuts as well, right?
Your T-nuts is where your wing nuts goes inside the grooves.
Oh, okay.
So the T-nut goes in, your wing nut goes through the long slot into the T-nut, and it gets screwed on, and then the screw that's upside down is behind it.
Okay.
So the head of the screw is pointing downward. No.
No.
Your
Okay,
wing nuts. You should have wing nuts, do you?
I got wing nuts.
But they go into the T-nut, into the slots.
So the wing nuts go into, well, the wing nuts can't go into the T-nuts. This is what I've got, a wing nut and a T-nut.
Show me. Oh, how many screws do you have? Okay, it's slightly different than mine then. So how many screws do you have? 4 or 8 of them?
3, 4, 5, 6 screws, 7 screws, 8 screws.
Okay.
So obviously the T-nuts have got to go into the slots.
Yeah, but just the screws go underneath them then, correct? Is the inside of the T-nuts, are the inside of the T-nuts threaded?
Threaded. Yes, they are.
Then screw one screw all the way up inside it, all the way through on each of those T-nuts. So the screw will point upwards when it goes into the V-slots.
Oh, I see what you're saying. Okay.
So screw it all the way in and tighten it all the way down. Yeah, mine doesn't have that. Mine has got like a bolt head, so it fits automatically.
You're saying something like that.
Correct. Now that should slide in to your V-slots. No?
Let's see.
Are all the screws the same size head?
Yeah, they are.
Because it's not countersunk inside the V slot or the T-nuts.
Well, let's just see something here. So this.
Was that a bolt? Or is that no, see, that won't hold in that slot, will it?
No, see, all the screws are the same. They all.
And you have no heavy bolts?
There's no heavy bolts. 6 of these same screws here. And I didn't see there was nothing in the manual about how to put these in.
Can I see how it fits the bottom of the T-nut?
Well, so we have it. I mean, here's the T-nut.
Yeah, the underside of it. The underside of it.
The underside of it, there's no countersunk on it at all.
So the screw sticks out, and when it sticks out, it won't fit in the V-slot, right?
Exactly, yeah. So if I screw this T-nut all the way onto the screw.
Okay, they're doing it all from on top then is what they're doing it, which is kind of weird, but okay.
Yes, because then that does not fit in there at all. So yeah, they're doing it all from top somehow.
Which I don't know how that would work. The reason why is the wing nuts need to go into the slot, but the other like.
Maybe I'm better off to throw this board on, because this board has a whole bunch of little threaded holes here.
Yeah, and you screw it down into it.
Screw it down into it, but again, these screws are too long.
Yeah, let me get one of mine from my other one. I'll show you what mine looks like.
It's not making a lot of sense here. Jam the screw into the base of the slot. No, it doesn't. There's nothing. There's no way to jam that screw into the base of the slot.
Okay, here's the way mine was set up, right? Mine had normal hex bolts at the end of mine that went into the V slots, but I 3D printed these.
Whoops.
It's okay. Mine had normal bolts that would actually go and be jammed in the V slot. And I 3D printed these as sliders instead, right?
Oh, okay.
And what I can do is this bolt, this is your lever against the base, and this is what tightens it down onto the part.
Okay. So the way they've got that then is just wow.
Are you sure there's no bolt like these inside with your set?
No, this was it. I'll double check. But no, everything else.
Because
everything else in this set is empty. That was it. That was it. So these T-nuts have got to slide in. There's how many T-nuts are? 1, 2, 3, 4 T-nuts.
So they might be reversing it.
Yeah, it looks like they might be, because the T-nuts, I guess it depending on what I'm cutting, but these T-nuts should slide in easily.
Yes.
Which they do. That slides in real simple. Okay, let me just.
How many T-nuts do you have?
4.
Okay, 4 T-nuts means that you screw down into it. Okay. And on the flat bar that you use for support, is one of those holes threaded?
One of them is threaded, yeah.
Okay. Right. So put in the 4. What you're going to do is one of your. Let me think this out now. The one in the slot is going to have a screw and a wing nut. So put the wing nut on it backwards. I'm guessing.
Oh, okay.
That way, then when you have it into the T-nut, you then, because that's the screw head, you then wind this down to put the pressure.
So we put it through the slot, and then a wing nut here.
No. One gets threaded in.
Yeah.
Thread that one in first.
All the way?
All the way. Right? About half the way would be okay, right? About half the way is okay, right?
And then a wing nut up here?
No.
Oh.
The other side, in the slot, you're going to put the other one in the same direction, but before you put it in, you're going to put the wing nut on it upside down. I'm guessing now. I haven't done a SainSmart, so it's different.
Right.
So put the wing nut on upside down. So the wings are actually pointing up towards the head of the screw.
Oh, I see what you mean. So,
like this. Look like this. Head of the screw, and your wing nut will go on the other way around, where the wings are pointing this direction. That's all I can. That's what I'm guessing.
So I have this threaded through like this.
Yeah.
Do we want the other one?
Well, before you do that, take it out and put the wing nut on backwards. Yes. The way they did this is weird. I haven't seen it being done like that before. So the reason why I'm saying this is now put that through the slot.
Like this.
Yes, and then screw that into, use a screwdriver and put it into the T-nuts.
This one into the T-nut.
No, the wing nut. No, the one with the wing
nut.
Wing nut
one into the T-nut.
Yeah.
Huh. Okay. That.
I'll explain why in a second. Just do one, and I'll show you why.
So
that should go into the T-nut. So yeah. All right. Now you got bite on the bed, right?
Yeah.
Don't tighten it. Just now, as you move up and now the back one, the screw on its own.
Yeah.
Loosen it. Take it out more of out of the slot. Yeah.
Oh, I see. Okay.
So what's going to happen is the part where the wing nut is, that part is going to slide over and sit on your part, and then the part with the screw touches the bed, and then you use the wing nut to tighten it down to put downward pressure on your part.
Okay, sort of like that. I've got a piece under.
Yeah.
And then the wing nut's going to tighten.
Correct.
Okay, I see. I can feel it. There we go.
Yeah,
I get it. Okay, that's really strange. And then this adjusts based on how thick the piece is.
That you can move up and down depending. Like some of the pieces could be higher. You might find that later on you might want to replace those with slightly longer ones because it looks like you don't have a lot of play on that wing nut. Or I replace it with a bolt like I have here. You replace it with a bolt that's the same thread size that will fit in there, and then the bolt would actually go into the V slot instead.
And this has washers as well.
The washers should go between the wing nut and the metal plate, like here, like in mine.
Oh, okay. Okay.
So you're not tighten it down onto the slot. You tighten down the washer against it is what you're doing.
Okay. Okay. So I got to take this one off now.
Yeah, just briefly take it off, throw the washer on, and then I just wanted to test to make sure it worked.
Yeah.
Because I wasn't sure how they do it. So
then the washer is going to go on here.
Yeah.
And then this will go in here under that T-nut. Okay.
Washers are directional also. It doesn't matter in this case. You don't have to tighten that one down. You just have to get a bite into what's below it.
Into the T-nut. Okay.
Yeah.
There we go.
So now once it's halfway or so into the T-nut, now it has to pull against.
Okay. So let's do the other ones now. So that's really wow.
Mine came with a bolt, so it was easy to find them. But what I did is I built this. I'll find the STL for this and send it to you. And if you can get the bolt for this, and it actually fits into the V slot. I think you have the same type of V slot as I have.
Yeah.
This is I made it out of PETG, so it's a slider for it. It makes it easier.
Okay. Yeah. This thing seems like it's cross-threaded. There we go. That thread was damaged. Yeah, Jerry. That's what Jerry says. Washers are directional as well. Yeah, I know. A lot of people don't think they are, but they do have a direction on the washer. Okay,
More so with spring washers, to be honest.
Yeah,
right?
yeah. Okay, so now we're going to...
General washers is not so much. I know you're kidding, but we're just giving you a hard time, Jerry.
No, but they are. They do. The washers, and they have...
That's just the way they're stamped, Tim. That's just the way they're stamped.
Yeah, but I always use there's to me an unfinished and a finished side, and I always leave the finished side up.
Well, that's because of the stamping. The stamping process curves the top when it stamps the metal.
Yeah, I don't know. I'm always putting that stamp side up.
Yeah.
Because it's the clean side.
Like there's some washers like they are because they're sprung washers or whatever. They have to go in a certain way. But so put in 2 on each side is what you need to do, and that's how you wedge your part in place.
Aha.
But you may have to move them around depending on the piece you're working on.
Yeah, well, I figure I'm just going to use this piece to cut for now, and that should hold them in on each corner, no problem. Yeah, that should.
Okay.
Okay. There's the other 2 parts here. That's why I think I'm going to like this board. This I call it the sacrificial board, because to me, then you get this in, you get the shorter screws, and all you do is put this where you want to put them to clamp the pieces in.
Well, no, what I would do with that is I would use a super glue and double-sided tape.
Oh, with that board? Yeah, okay.
Super glue and tape. So I tape the board. I tape the underside of my part.
Yeah.
I put the activator on the board, the super glue on my part. I push them together, line them up and push them together, let it go hard. And now I don't even need clamps because it's stuck in place. It's going nowhere.
And I have some of that glue and activator, so that's, yeah. Okay.
And then all you need is something to pry it off afterwards and peel it off and you're done.
Yeah. Okay, let's get this. Okay, wow, I never would have figured this out. Thank you. This is kind of weird, but now the way that it's on here now, it does make sense. It works.
Yeah, but
it's almost like
the glue is the better way to go long term.
Yeah,
the glue is the better way to do it.
Oh yeah, because I can see this. If I want a bigger piece, I've got to move these to the outer ones, and yeah, the glue definitely, the board and the glue.
Old curmudgeon is saying that the desk camera you have is down $67 on Amazon.
This one? Oh, or this one?
I think it's the arm one. I think it is. He's mentioning.
Oh, okay, wow, that's a good deal because it was over $80 initially.
Yeah.
Wow. I don't need the second one. Let's get this in. There we go. And then now where's that last bolt? Oh, sure. Did I lose a bolt? There it is. There you are. This is probably more complicated than building the CR30 would have been.
Maybe.
Yeah.
Well, it's new to you. That's all.
It is. It is.
That's all it is.
I've gotten a bit of use out of my laser. I'm loving my laser, so I figured this is going to be a good little add-on to my laser, because I could laser and then CNC, or CNC then laser.
Or you could do a combination, and you could even do CNC out a part, and then 3D print the inserts and insert them into the part of CNC'd out.
So if I have this on here, I should be able to take this.
Get your part lined up first before you. Yeah, okay. Make sure it's tight, because it will be that cutting tool will be putting pressure on the part.
The in my other business, I have a guy that does CNCing for me on the big machines. Yeah. And he's got a big wooden base, and all he does is he takes his substrate, because he cuts it out, right? Mm-hmm. And he just screws the substrate right to the bed.
Yeah, and he leaves little tabs, and then he takes off the tabs afterwards. Yeah. Yeah. On a bandsaw or something like that.
Depending on the material he's cutting, he cuts everything from steel to aluminum to all sorts of stuff. Okay. So we have that. I'll just put all 4 on here just to be safe. Oops. Don't want that falling out the end. Come on. There it is.
There's alternative clamps you can get for this as well. What some people do is the back screw that you have there, instead of using that, they use pieces of wood because they tend to damage the aluminum bed.
Yeah, that makes sense. Put a piece of wood under there for the lever.
People get little pieces of wood. Like you can actually, you can even 3D print parts that are stepped, and the different steps give you different heights in the back, and then you clamp down against it.
If only I knew somebody that had a 3D printer. No.
Yeah, I know. Yeah, they're really hard to find.
That's in there very solid now.
Yeah, that looks good. Okay.
Okay. So, now is when I want to probe it.
Now you want to you will let's plug in your probe first of all into its port, and then the little Jubilee, the little clip, the alligator clip goes onto the bit, onto the cutting tool. And then the probe goes on the surface. And let's do it all through Gerbil, okay?
Yeah.
Or through your PC. You can probe through that, but let's do it all through the PC for now.
Well, maybe I've got the Y too far up.
No, you can just watch when it's homing, because the bit is sticking down, that if because you'll have to home before you initialize it with the software.
Right. Doesn't want to move at all now.
Because the PC is connected.
Oh. So let's see if I should be able to move it with the PC.
Well, we need to configure on the software to talk to it. So let's go back to the software.
Okay, let's
bring it up on screen.
And let's bring this up. There we go.
Okay, so let's forget about the offset for now, because there's a way to do it without the offset, right?
So
go to settings.
Settings.
And you need to set your COM port.
Huh.
It's not seeing it.
Oh, right there. Just refresh COM4. It must be COM4.
Okay. And do OK. Oh, wait, no. Before you do it, sorry, go back in. Sorry, forgive me.
I've got live buttons now. Yeah.
Yeah, go back in. We need to set the size, the physical size of the machine.
Oh, I see. Okay.
So you have the speed machine there, acceleration of 100. Machine information, yeah.
Machine, nothing's changing. Why isn't it changing?
1 second.
Oh.
1 second. No. Hold on a second. Your baud rate is good. Spindle speed. Your spindle speed is what? Is it an 8,000 or 10,000 RPM?
It's an 8,000.
So change the spindle speed max to 8,000.
No, I'm sorry. It is a 10,000.
Okay.
It is a 10,000 because the next one I can get is a 20,000.
Okay. Yeah. Query period is okay. I would say okay to that.
I would imagine that.
Now, let's do I can't see the far right. There should be a home button there.
Let's see if I
top icon, all the way to your left. To your left.
This one, home.
Is it moving?
No. Let me unplug this. I plugged the probe in, and it sort of killed everything.
It's not a probe. I don't think it's a probe. I think it's.
Huh.
Your PC is in there. Go back to the machine. Go back to the PC, and click on the home button. Oh, sorry. Forget. Click unlock first of all. See the lock symbol? Click the unlock button.
Oh, alarm.
Click the unlock button.
It's in status alarm for some reason.
Click the reset button right beside that. This is now click the home button. Try unlock again.
Yes, I remember seeing something about the alarm status.
Yeah, but you should be able to clear that by clicking the reset.
Let me restart the software.
Okay.
I got to come over to this screen here. Oh, no, that's not where it was. It was on Candle. There we are, and then Candle. Okay, how come you didn't launch?
Did it launch in a different window?
Yeah, that's what I'm looking to see. Oh, come on. Dum, dum, dum.
Well, if you keep calling it, it's going to open up 50 then in one go.
Yeah, but it's not even showing up on my taskbar as being launched, right? So,
Yeah.
Damn.
I think we can run the test ones without it, right?
Yeah.
So what you're going to do is, using the hand controller, move the position the cutting tool roughly where you want it to be on the board. Let's say top right and top left corner. Use a hand controller.
Okay.
We can figure out what's wrong with the software in a minute.
Let's just see.
Maybe you need to reboot the machine or something. I don't know. But so use your hand controller and move the.
Yeah, I'm gonna unplug the USB for now.
Okay.
See, nothing's moving now with the hand
You'll
controller.
have to. You might have to reboot because of the two being connected.
Right. Okay. Let me restart this.
Yeah. Shut it down and restart it.
Restart it. This isn't hitting a limit switch.
No. Is it up?
Nothing's working. Let me check all the connections here. Make sure I didn't loosen any connections. Oh, you know what it is?
You hit the cutoff.
I must have accidentally hit the cutoff. Yeah.
Okay. So
let me try the computer again.
Okay. Well, we don't need a computer for the test files. So what you're going to do is get a piece of paper. You're going to like a 3D printer. We're going to bring the head over to where you want it. So move it in an X and Y, and then with a piece of paper on it, bring Z down, and give yourself about let's say about 2 or 3 inches down from the very back of the part that where you're going to engrave. And let's do the SainSmart logo.
Yeah. Okay. So first of all, let me move this up into the wood so that I can bring the piece of paper down.
Yeah.
So I don't need the probe on this at all now then, yeah?
Well, we haven't set the offset, so you don't need the probe yet.
Oh, okay.
We can do it without the probe.
So you're saying put a piece of paper down here.
Yeah, and then in the menu, what you're going to do, and then what you're going to do is wherever you bring it, make sure your position is well in.
Yeah.
So bring it in, into maybe 2 inches into the part, and then away from the edge, like so it won't impact any of the clamps by maybe 2 inches.
Yeah. So I've got it right now. I've got it. Yeah, I've got it right
now. Bring Z down.
Now we'll bring Z down
and put a piece of paper under Z. And when you get really close to it, drop it down to 1 millimeter or fractions of a millimeter. Okay, stop there. Now go down, set the distance a lot less.
0.1 millimeter.
Okay, that'll take a bit of time, though. The paper should just start rubbing rubbing it.
Right there. I can
a little bit more. Should just be catching it.
There.
Right. Okay.
Yeah.
All right. Now take out the paper. So what you're going to do is into the menu, you're going to home XYZ. Or no, 0 XYZ.
Okay. So I'm going to go into the control.
Yep.
Enter. And I'm going to go 0 XYZ.
Yeah. Now that's the home position as far as it's concerned.
And enter.
Yeah.
Okay.
Now you can move Z up, and it goes up in a negative number. So now when it comes down to print and cut, it'll come down to that point and start cutting.
Okay.
Now stop there. That's enough. Now
That's enough.
Put in your USB into that machine, into the hand controller.
Okay. Okay. Everybody watching, this could be fun. How many people are watching? 18 people to witness this. Okay, SD card in.
And
I should be able to go File.
File and select the SainSmart one.
File select. How come there's no? There we go. G code.
Well, no, you're looking for the NC files.
Oh. Okay, file, enter. No, there's no files showing up. Why? Let me go back and see if they're not in the root directory, maybe.
Maybe, because you can't navigate folders. Okay.
Yeah, let me just go see what directory these things are in. There might not be in the main directory. Let's just have a look.
And there's no option there to navigate folders, no?
No.
Okay.
So here is, I think you can see it on the screen there now. There's the card, so they should be there, right there on the root directory.
So maybe it only reads it on boot up.
So yeah, there it is there.
Yeah, so maybe it only reads the SD card on boot up.
Oh, okay. Okay, so what I'll do is we'll get rid of that.
Yeah, so you'll have to re-zero it again, like we did by bringing the Z down.
Yeah. So what I'll do, first of all, let me just turn this off, put the card in.
Yeah.
Turn this on.
And let's see if it sees the files.
It sees the files now. Yep.
Well, it's only on boot up. All right. So now you're going to do is you're going to bring Z back down where it was a while ago with a piece of paper and 0xyz again.
Okay. So we'll do this.
Let me get the one that I have for my one. It's different than yours.
Okay.
So the one from my CNC is a touch screen.
Oh, okay.
It's the R2 one is it's the same as the one they have for the laser.
Okay, so I got the Z down, so I'm going to go Control, and I'm going to go
0xyz.
0xyz, enter.
Now that's your home position now.
Okay. Then we can get out of there. We can raise the Z up. Oops, we don't have to do it by 0.1. We'll raise it up 10. There we go. Okay.
Okay. Now you should be able to select File and hit and select and run. And the spindle should speed up first. Now be ready with the stop button just in case it doesn't anywhere because it's a first run, right?
Okay. I'll do the SainSmart.
Yeah.
And ready, go.
I think you have to hold the go button.
Oh, okay.
There we go. Now you're cutting.
Whoa.
And no magic smoke.
No.
So basically what we did was we brought it down and said, this is our starting point. Because remember when you brought it into the software, you could see the start point.
Okay.
We forced the start point to be where we wanted it to be on the bed.
Okay.
Now the Z probe does the same. It just does a Z offset for you, but you can do it with a sheet of paper. You don't need a probe.
Okay. Let's see what this does. It's not throwing a lot of dust, I can say that.
Not right now because it's only using the V-carve bit, which doesn't make a lot. But it will make very fine particles of dust, though. But it's
right.
Much. Yeah, Jerry's saying you need to be wearing glasses, safety glasses that come with it.
They didn't come with safety glasses.
Oh, well, they should
I'll
be.
get a pair of those over the glasses ones.
Well, it's going to be an enclosure mostly for you, right?
Yes.
Then it's not that big a problem.
So I won't go really close to it. No.
No.
We'll just let it finish its job here. Oh, that's cool. My first time CNCing.
Yeah. So we're good. When this won't take long. It's only text. When it's done, we're going to move it. We're going to move it further. We're going to move Y further back, and then we'll try the wheel one, and that will actually cut out a design.
Oh, okay. Well, let me see if I can get this camera on here. See if this is any.
Yeah, turn on the light. There you go.
There we go. That way I can come over and watch it on the computer screen instead of looking at it on the board. Looks messy, so all the dust gets taken away.
So Jerry is saying next week you're going to have a patch in your eye. So we'll call him Tim the Pirate. Now, when you're doing a V-carve like this, it's not very noisy, right?
Right.
The spindle is noisy, but the V-carve itself is not. When you're doing flat end mills to do like the clear out areas and stuff like that, they get noisy. And you move slow. You move. You can do well. You can do medium, maybe 400 millimeters is what you set it to.
Yeah.
Whereas some of the others, you need to do them really slow, like the one you have for flattening out the surface. That you only run that. First of all, you need a 6 millimeter collet. You don't have one of those because the EI11 is the collet you have right now is a 3 mil collet.
Yeah.
And so, yeah, there you go, SainSmart. Congratulations, you just did your first CNC job.
It looks better on camera than in person.
So,
there we are. It's the lighting.
Yeah, it is. Yeah, it looks really good. So
nice.
That's the outline, right? So
yeah,
let's move the Y further back, and then we're going to home XYZ again, like we did a moment ago, and this time we'll run the wheel. So bring it over into the middle of the part. I would say move it over to the center as well. Yeah, let's try it there. Yeah, give yourself a bit of space. I believe this is about 3 inches wide or 4 inches wide.
It should be the same offset, though, shouldn't it? I shouldn't have to probe Z again, should I?
You don't have to probe Z, no.
Nope.
But you have to set your X and Y home.
Yes.
Changing your home for X and Y.
Okay, so this one here, I will go control.
Yeah, and
then
XY. Because your Z is going to stay the same. You're just changing where it's going to be cutting.
Okay, now we'll go file, and then we'll do wheel.
Yeah. Be ready with the stop, remember? Down it comes. It might go into the same. Is it going into where the SainSmart is? It is. Oh, well, that's okay.
Oh, it stopped.
Did you hit something?
No. No, let me. Alarm. It says state alarm.
Okay.
Oh, maybe it looks like it's. Oh, it hit the. It's basically so.
Just touching the wood, right? Just barely across the wood.
What it looks like is that the Z is too low, though.
Oh, that could be a situation. Yeah, that's possible because it wants to go deeper. So you might have put another part underneath it.
I might have to put a wood underneath it. Yeah.
Yeah, that happens. Yeah, depending on how deep we're going, there is a limitation on the Z. That's why the sacrificial board raises it and probably solves that most time. But just double the part is what you do. Just put two pieces together.
Yeah. Okay. Well, what I'll do is let me repower this so I can get that Z lifted.
Yeah. And you'll have once you power it off and on again, you'll have to re-zero your Z. Okay.
Yeah, but I'll have to put something underneath it here. There we go. Okay. So
maybe a piece of 1/4 inch ply or whatever if you have anything like that.
Actually, I've got the other board here. Oh, this I can actually turn over and use the other side.
Yeah, that's a good point, non fam. At least you know your Z min, your Z max.
Oh yes.
Or Z min works, yeah.
Yeah. But if I put that board on the sacrificial board, it'll be plenty.
Yeah. Oh yeah, yeah.
So for now, I'll just put.
Well, you must remember the sacrificial board may not always be enough because the height of the sacrificial board may not be high enough to bring it all the way up.
Right.
Yeah, that'll do it.
Let's see if I can.
Hey, Thomas, how are you? Maker Vikings in the house.
Ah, hey, Thomas. Now, am I going to be able to clamp this?
You'll have to drop the screw in the back, maybe. Loosen, bring it out further so you have a bit more distance.
Oh, there we go. Now I'm just going to screw this one down.
Yep. Now that you know where it's starting, you can move the board far enough north so it's actually going to start the wheel below the SainSmart text.
Right. Okay, let's bring this up.
Oh, you've been working on your printer. Nice.
Okay, there's that side. And I think there's one on this side is going to be plenty. This is clamped pretty tight.
Yeah, okay, one would be enough as long as it holds and doesn't shift when you're cutting. Because there's the two things happen, right? If it moves, one, depending on the part, it might go flying across the room because of the spindle. But the other thing that's even more dangerous is your cutting bit, your cutting tool will shatter.
Yeah.
And you do not want that flying across. It's hardened steel.
That is extremely tight.
Okay.
Okay. Let's try it. So now I got a 0 again.
Yep, 0 it all, just like we did a while ago.
Okay. Now we go 1. Okay, now we go to 0.0, 0.1.
There, yeah, that looks about right.
Yeah, right there. Now we'll go select Control 0 XYZ.
No.
Oh,
Well, you can. I suppose you're in the middle of the part. It's a circle, so you should be okay.
0 XYZ.
Yeah.
But now I got to go 0 XY. Okay.
No, you don't. Oh, you only have to do 0 XY if you change the XY position.
So I should, but I think I'll bring this.
You want to move the Y back?
Down. Okay, I'll start where it is.
Yeah, it's just going to go through the text. It doesn't matter. The text is only an outline anyway.
Okay, and let's go to wheel and go. Ready? There we go. Okay, that's carving now.
But it's moving much slower. So it's doing a V carve right now.
Because it's going deeper.
Yeah. But it's moving much slower because of the type of bit.
No, I'm stopping it. It's going to go right off the top edge.
Oh, okay. So you need to change position.
Yeah.
So while you're at it, flip the board upside down.
Yeah. So once I stop, okay, if I pull that.
Here's what you do, Tim. Move the Y back and then home a little bit. Because if it's going off the bed, it means it's not home right.
Yeah. Okay, let me just
move Z up. Yeah.
Move Z up.
And then move Y forward.
I'll turn the board over.
Oh, you don't even have to. You just move Y forward as well.
Okay.
Or move Y backwards. And then home XY. That means it'll give you a new start position, which is further down the board. Tim, you're fired, Jerry said. That's too far. You said it roughly in the middle of the board. I'd say you're too far down. Yeah. Okay.
Right, that's about square middle of the board, right there.
Because you know how far it traveled a while ago, right?
Yeah.
So you want to offset that in enough so when it cuts, it doesn't cut outside.
Okay, there we go. So we 0 XY. And we'll go back.
Yeah, Lama 0. It is when you home Home is front left corner, but you can change that. That's a G code command. You can change that.
Yeah, I
But
guess it
he's doing
depends.
manual alignment right now to do a test.
Yeah, manual alignment right now. Okay, let's try that test again. Let's see what it does.
You would have to. Yeah, you also have to zero your Z because you powered it off. Remember?
Because I went, oh.
You have to zero everything again.
Yeah, that's true. Good point.
Hey,
Okay.
John. Hey, tripod. Oh, too much.
Whoops.
Too much.
Too much.
Yeah, you had it traveling too much, too fast.
Oh, well, that's okay. I just got a big hole in the middle of the wood is all.
Well, that's okay.
That's how we learn, right? That's like crashing your nozzle into the bed.
Yeah, but this pierces through where the nozzle sticks there and pushes the springs down.
Yes. Okay, so step 1. Here we go.
Yeah, small steps.
Now
Baby steps.
Rookies, you know.
There you go.
There we go.
Right. So I would probably shift it a little bit to your left, to the left as well.
Okay. Let me set XYZ first because it's going to, yeah.
And then move it up and then move it a little bit to the left, away from you. Go on. Okay, there.
There.
Yeah.
Oh, 0XY. Okay. Now let's try.
See if it works. Or did you unlock the stop button?
Yes.
Okay. That looks better. Much better. And I would step back a little bit, Tim, in case just in case a bit breaks, you don't want to hit you in the face.
I'll stand over here.
Yeah, a little bit of distance, so if that cutting tool shatters, you don't want to hit you.
Well, what I'll do, no.
That works.
There we go. I put the box over it.
That kills it out of sound, actually.
So I've got, I threw the box over it, so if something does happen, it's protected.
That's a good idea.
Yeah, and it's going to fit in that position too. Very cool.
This will take a little bit of time, maybe 10, 15 minutes.
Oh, you think that'll take that long?
Yeah, because this is just the inside, it has to do the outside of it as well.
Oh, okay, okay. Well, this is going to be kind of fun, and then I guess I get to learn what all the different bits are for.
Yeah, so the V carve is for creating slots or very fine detail. Yeah. The flat end mill is mostly used for clearing. So if I did an area, let me find if I have one here. I think I have a picture of it on my phone. I did a few, and let me try and find them.
I need a little vacuum cleaner down here.
Yeah, you need a vac to clean up.
Got a
You
shop
do.
vac upstairs.
And you should clean it as you go. Every now and again, put in the vac and clean it out.
Yeah.
Especially with V carvers, not so bad. But when you're doing clearing cuts with the
Yeah.
flat end mills, there's a lot more debris, and you need to clean it out regularly.
Yeah.
So here, if you're doing something like this, you see that? So all of the big wide area that's flat, I mean that because that's all inserted, indented.
Oh, yeah.
That's done by a flat end mill.
Okay.
And then I changed from the flat end mill over to a V carve to do the detail. So, and in your slicer, you set that. You leave maybe 0.5 of a millimeter behind, and then you use the V carve bits like that to do it. Or you use a very small round ball end mill to do final detail as well, depending on the finish you want.
Okay.
So here's another one. This is actually work in progress that was already done.
Oh, that's beautiful.
So the rough cuts was done with the flat end mill, and then the V carve is basically going over and back, making slices like a printer does, over and back.
Nice.
But it's doing it's going over and back and carving out that fine detail.
Oh, okay.
See that line there? That's an imperfection in the wood, in the plywood.
It looks like a mistake. But
yeah, but that's beautiful detail though.
It is.
That's what that's capable of.
Is it really? Wow.
Yeah. So
in the right hands.
Yeah, so it's very, very. You can do a lot with them. They say aluminum. I probably wouldn't do aluminum with it. I would do wood. I would do acrylics. I would do hardwood. For hardwood, I would go even slower than I would for softwood. But I wouldn't do aluminum, even though they say they can. I wouldn't go there. What's a Walter, Jerry? You should carve a Walter. What's a Walter?
A what?
Jerry said I should carve a Walter. I don't know what he means by that.
A Walter? I don't know.
No clue.
Looks like it's going around the final circle now.
Yeah.
I can have fun with this because what I want to use this in my business as well because I often get calls for nameplates.
For aluminum plates, you could use if you want to do like aluminum tags. You can probably do tags engraving with this, but like the easiest thing to do with tags is to get anodized steel, anodized aluminum, and just laser off the anodized, and you get silver names.
Yeah, well, yeah, because I have aluminum composite that has a very thin layer of aluminum, and then it has black underneath. So if you get rid of the aluminum, the black shows through.
Now this could probably do it. I've done that type of work before. I haven't done it with 3040. You want to test it? It's like a bakelite in the middle, the plastic, the aluminum sandwiched. That's done. So move your Z up and then take out the part.
Why isn't it stopping?
It's done.
Yeah, the motor's not stopping though.
Oh, it should. Maybe that's a problem in the G code. It didn't shut it down.
Yeah. So that's when I take this off. Whoops. And I'll just hit the stop button.
You should be able to stop it in the menu somewhere. I don't know that menu, but you should be able to stop it in the menu.
Let's see. Enter to pause, continue. Stop. No. No, I'm just gonna.
Okay, I don't know. Like, and my one, I have the option to hit the kill, but you stop it. So let's. Do you have it? Take it out. Let's see what it looks like.
Okay, let me just raise that out of the way a bit because that's pretty tight in there.
The one, all commodities made a point there that the speed is very important. So for soft woods, you do about 400 for V.
Okay.
For a rough end mill, you could do a little bit faster than that. But you can't go. You want to be careful that you don't go too fast because basically, if you go too fast, your end mill is pushing through the material too fast and faster than cut, and you break your end mills.
Okay, let me just blow this off. Well, here, this is what it looks like.
Tap it into a.
Before I blow anything.
Tap it into the trash. Don't blow it. It'll go everywhere.
Yeah. So let me tap it, and we'll see. Needs to be cleaned, but I need a blower because it's
a little brush or a vacuum will clean it out.
Yeah.
So did it. Nice. Now, the way we zeroed it there, right, with the software that you have in your computer, you can zero it in the same way, but you control it via the software.
Right. So.
Also more than finding a blowhard.
Yeah, the more I blow, the better it looks.
Well, a vacuum will clean that out. That's why you vacuum as you go,
Yeah.
so you clean it out as you go. Oh, I'm not going to comment. I'm going to get in trouble.
No, I'm not.
Soft brush will do it, Kieran. You don't even have a slip on. A soft brush will do it. The vacuum cleaner would get it out too.
Vacuum would do it, yeah. But I mean, that turned out really nice. That's clean.
Yep. So it's nice and clean. It's easy, and so in the software, as I said, you can do the same because you bring it over. If you don't set the Z offset, which you can do at some point, you can bring it over and Z it in the same way, but use a software to drop down Z, and then home it, and then zero X, Y, and Z or whatever you want. Go.
I got it all.
Okay, so it's official. Tim is full of hot air. He's blowing it out. If he keeps this, he's going to pass out soon.
I got most of it out.
But it looks good.
Yeah, it does. It does what it's supposed to do.
Now, that's only outline. So what it does in the software, whatever is dark, it will cut. So if you filled an area in, it would actually go in and clear that area out for you.
Yeah. Old curmudgeon, I did get it. Yes. And I should have responded, but I had a week last week.
Was full of hot air.
For when he hyperventilates and passes out. Yes, I could pass out.
He's going to faint in a while. He's blowing so hard. So what I've learned so far is that this, without just to put something thin on here like this, you're not going to really cut anything thin. No.
Or even engrave too deep because of the limit of the Z here.
Now, there's a way to fix that. You can loosen the connection and drop your spindle lower.
Okay. So just lower.
Don't go too low. You need to be somewhere in the middle of the spindle. So as long as it's good grip, you should be okay.
Because when it's set up, there's a little bit of there's a tiny lip. I don't know. You can kind of see.
You can go a little bit lower than that if you want.
And that's what they suggested you line it up to, though, when you've got it. I've got the laser module coming for this too, because I want to try laser on it as well. Yeah, because you can never have 2D lasers. So, but the laser module fits in here as well.
Yeah, so it's not hard. And as I said, you can zero it out the exact same way in the software. You just need to learn the software.
Yeah,
and you can zero it in the same way in the software. And then you hit go, and it does it. Now, if you have a part that you have, like if you're doing the same part over and over again, and you have a template for it, do one, pick it out, put in the next one. And if you're doing clearing, what you need to do is when you're doing a clearing out, let's say you need to clear out a large area, like I showed you images that I showed you a moment ago. What you do is you use a flat. You'd have to slice it differently. You create different tool paths, like with easel, or you do it in either easel or you do it in Fusion 360, and you do multiple tool paths. So you create multiple files. So one would be clearing file using the big end mill, the flat end mill. And you do multiple paths to dig down the depth you want. The second one will be with a ball end mill to clean it up a little bit more, and then the third path will be fine detail. And I can show you how to do that kind of stuff on Fusion. It's not hard.
So if I plug the USB in, do I have to unplug the controller?
No, try it now. I think it's because you hit the stop button triggered the last time.
Yeah, so let me bring the screen back up.
Yep.
Now let me go back here.
It's weird.
I couldn't launch the software before, that's why. Let's see if it'll Candle. And then if I launch Candle, it wasn't, it's launched. It's almost like it's being hidden in some other screen.
It could be.
Let me check this chat screen.
Well, it's not in your taskbar, which is kind of weird.
Yeah.
Maybe you need to bounce your machine. You can do it some other time. And I can help you. I can at any time I can jump on and help you out with it, like separately. And then you can do some short videos about it working with Candle. But
Right.
I will recommend Fusion 360. I think you get better tool pathing with Fusion 360.
Right.
Candle is free, so is Fusion, but Fusion you can do better tool paths. I think they're more optimized. And I started with Candle, like long ago, but now I use Fusion because like I did. My dad was a carpenter, so we did some CNC back then with him as well, right?
Right.
Engraving wood, but Fusion is way better, I think. And in Fusion, you set up your tools inside the Fusion. And
Yeah.
once the tools are set up with Fusion, you then just pick the tool and then you set how much material you want left behind. There's a whole pile of settings of speed and feeds and all that kind of stuff. But with the output is really good, like that Mars one and also the Swan one, the image I showed you. That was all done by Fusion. And in
Right.
Fusion, you have multiple options with Fuel for when you're doing the fine detail. You can do it over and back. You can do up, down. You can do it in circles, in concentric circles moving in. There's a whole pile of options available to you for setting that. And you can even do stuff like, this is designed just to clear what's there, right? In Fusion, you can move the part deep in a piece of wood. So if the top of it is uneven, you move it down and it will clear it all out down to where it needs to be, and then start the details.
Right.
So you can do a lot with Fusion.
Right. Right.
Fusion's not complicated. I don't find Fusion complicated.
I've done some pretty intricate designs in Fusion so far, but I've never thought of Fusion for tooling.
And the nice thing is you can get an STL file in Fusion and import the STL file as a mesh. You do a mesh import.
Yeah.
And then in production in Fusion, you create your toolpath. So even if you see something that's three-dimensional that you like as an STL, you can bring it into Fusion and actually turn around and CNC it.
Right. Right. Well, what I'll do is I want for simple stuff. So if I want to do nameplates or something, I should be able to take an SVG out of Illustrator and then import that SVG into even Candle.
You can bring it into Candle and use Candle to do it.
Maybe that's the way I'll just take the baby steps.
Now, an SVG is a flat image. So basically what it's going to be is one pass with one depth.
Right?
To go multiple paths deeper, you need to turn it not only an SVG, you actually need to make it a three-dimensional image, which you can do in Windows 3D Draw.
Okay. And I see that's exactly why you're talking Fusion, because if you want to do three-dimensional multiple depths, you need that 3D image.
You need to have the depth because it needs to know how far down to go, whereas an SVG file is a flat image, two-dimensional. You need to go to three-dimensional to go for depth. So but what you can do is you can say how deep it goes and then make it move slow so it does it in one cut. But you probably don't want to do that. You probably want to do multiple passes and get it that way.
Yeah. No, that's cool. It's for my first time doing a CNC, I'm pretty happy with that.
Yeah, you got good results first time around. So and they were test files, but still, it's learning how to do them yourself is the next. And if you want at some point, I can jump on and with Fusion and we can walk you through the process, or we can do it with the software that you have already. We can do it on that as well. But you have to make a 3D image to do it.
That smells nicer than lasering too, because it doesn't burn the wood.
Yeah, it's just the smell of the wood is nice.
Yeah, that's great. No, that was awesome. That gives me something to play around with. I'm going to put the sacrificial board on it. They don't actually call, what do they call it? Not a sacrificial board. I forget what they call this, but anyway, I've heard it called a sacrificial board. But yeah, I think I'll put that on it. That'll give me that way I don't have to adjust the spindle at all. And then I'll try your tape with glue method as well on some.
Yeah, so you tape on the board, tape onto the bottom of the part, activator on one side, glue on the other, push them together, line them up and push them together, and then it'll harden instantly, and then you pry it off afterwards.
It seems like it'll be a heck of a lot easier than messing with these things.
It is.
Like
way easier than messing with those.
Because I mean, these work, but if I'm doing little jobs, to have to fiddle with these things, and if I'm switching out lots, is what a headache. But
Yeah.
Yeah, I think I've got these. I may as well use them.
And like you can always get those, like they're only pieces of MDF. So
Yeah.
you can get anybody who's got a chop saw to cut that for you and drill it out. So the one that you have that's good, that's not touched, still in the pack,
Right.
keep that and
Sure.
cut others, and you can get the screw inserts for it as well to go along with it. But you don't even need it. You just need it to be able to bolt down in 4 corners,
Yeah.
so it doesn't move. And
Yeah,
that's
this is all fancy because it's got all the hold down areas on it.
yeah, but you won't need those if you're going to use a glue.
No. But hey, may as well, and I got a free one to boot. So hey.
Well, use the free one to get somebody else to cut them the right size and drill holes and countersunk holes. So then you can actually drill out the holes, and then you can just bolt it in whenever you want to change it out.
Yeah.
Have it set of them.
That's true. Good point. Well, this was great. I'm happy. I'm happy with the result of that. I mean, it's a test file, but I've got to learn the software. I've got to learn a little bit more. Wasteboard. That's what Jerry's got. It's called a wasteboard. Spoil board. Yeah. I like sacrificial.
Yeah, the people, different people call them. Basically, all they are is pieces of scrap you don't mind cutting into if you need to. Because when you're cutting with the end mills and you're cutting through a part, so you can almost if you're doing coasters out of a solid piece of wood, you want to cut all the way through and leave little tabs on the corners. And then when you're done, you cut the tabs off, and then you sand them down, and then you have a finished part, right?
Yeah.
So that's what that's for.
And I know some of these other bits I got, if I wanted to say cut a certain shape of acrylic, it's one of these bits I think is used for that because it just basically cuts the edges out, right? So I'm not going to use a V bit for cutting out a shape.
It depends on what finish you want on the sides, right? If you want the flat sides, you use an end mill. If you want an angled, you use the V bit.
Oh, so it gives a chamfer type thing.
Chamfer, yeah. And then again, it depends on your you got 60-degree bits. You can get 45-degree bits. You can get 30-degree bits, and so like you could do straight on the sides, and then come in with a 30-degree bit and just go around it just to give it a slight chamfer on top.
Right, and
that's all possible, you know.
And actually, the chamfer shape is going to depend if I can get one of these bits out of here.
On the angle of the bit.
On the angle of the bit and the depth of the material.
Yes.
Theoretically.
It depends on how deep you want the chamfer to go. Like you can only do a chamfer around the top edge or all the way down to the end if you want. But they're 60-degree bits.
Yeah, and so this would go through a 3mm acrylic, no problem.
But you do it 3 millimeters it would, yes.
Yeah, okay.
But you'd have to cut slow.
Yeah.
Going 3 mils in one pass, that's a lot of strain and pressure on the bit. So you have to move really slowly, and you have to clean out behind it as it goes.
Because it would, on acrylic, it would melt the acrylic too, wouldn't it, if I go too fast?
So you're better off to do 0.5 mil down per pass.
Yeah.
You do 6 passes to cut it out rather than doing it in one.
Makes sense.
With the flat end mills, with wood, you can do 1 mil. And again, don't go too fast, but you can do 1 mil per pass. But with the V bits, the tips of those break too easy. So you want to go very, very slow. And you may not, you might actually crack acrylic as well. So yeah, that's a possibility if you force it through it too fast.
Right. Oh, these little...
You learn, if you break a few, you learn to slow down next time. Right?
Those little bit covers stick to the nose really well. Anyways.
I've never tried, and I have a lot of them.
Never tried taking one of these bits and just suctioning it to your nose?
No.
Okay. Well, that's just me.
But now you can get a collet set as well for this. Remember one thing: you can get different collet sets. The ER11 collet set, and then you can get instead of having the 1/16, which is 3 mil bits, you can get 1/8 inch bits or 1/2 inch or 1/4 inch bits.
Actually,
it's a collet set.
I think these are 1/8 inch.
They're 3 mil.
3 mil, yes. And then because this one here,
3 mil is 1/16, I believe.
This bit needs a bigger collet.
Yeah, so in that one you need a 6 mil collet, and you can buy a collet set. They're not expensive, and you just pop the collet out and you pop that one in instead. Yeah,
and this will do edge cleaning or surfacing.
That's for surface leveling, really, not really for edge cleaning, but more surface smoothing to make it all parallel
Right.
with the bed when you're doing stuff.
Makes
Now,
sense. Perfect.
that you would probably use that on your spoil board or
Yeah.
sacrificial board to let the mix shoot to level that, because the wood was not always uniform.
Yeah, exactly.
And
Especially
with that,
MDF.
you do a 0.2 millimeter pass and see how it goes. And if there's nothing to be done, then fine. If not, you drop it down and do another pass of 0.2 millimeter. You re-zero your Z and do
Yeah.
another 0.2 millimeter, and you do that just to take off the bare amount, just to get it all even.
I kind of like we didn't get to use this, which is fine, but I kind of like your method of zeroing anyways. To me, it's just as accurate.
Well, by doing this, what happens is you set it in the software and you do a zero with the probe, and it automatically zeros. It comes up and comes down quickly and touches it, backs up, and then comes down slowly. And then after that, that's all you have to do. That's your Z done.
I get it. Okay. I just have to figure out the exact. Yeah, it was a little confusing as to which number to change in there. I'm going to have to figure that out.
Yeah.
I
use both. I use both options, but the paper is just as easy. It's like you do it all the time with 3D printers anyway, so there's no difference.
Yeah. Well, this was great. Thank you so much, Liam.
Of course, happy to help.
That was a great help.
CNC is fun. You can get really creative with CNC. You can have lots of fun with it.
Between this and laser, I think I'm gonna. I don't know. It's kind of taken my mind away from 3D for a bit, right? Because
well, it is 3D, but instead of adding material, you're taking the material away.
Yeah, and I love the smell of the burning wood, and I like the smell of the carving wood. It's just, call me weird, but it just brings me back. I don't know, to the days when you used to have a lot of campfires. So.
I will say one thing: do not do MDF carving without ventilation, because the fumes from MDF are bad for you.
Okay, and I can't see why I would, but MDF seems like it would be real messy too.
Yeah, well, not messy, but the particles are actually bad for your lungs.
Oh, okay.
It's like oak. You can do oak, but make sure you're well ventilated, because oak particles are also bad for your lungs.
Yeah. Perfect. Well, I'm going to consider this a successful stream, and thank you very much for coming in and helping me out with this.
Happy to do it.
I'm going to pop you out, and I'm going to say goodnight, and then hopefully next week we're going to be with the CR30. We'll see what happens. We'll see what I can schedule with Mr. Cleveland. So thanks, Liam.
Anytime.
Much appreciated. Talk to you soon. So guys, let me just stop that screen and let me just say goodbye. Listen, thank you everybody for watching, and especially thank you to Liam for helping me out with that. I learned a ton. So I'm going to have fun practicing with this. I'll do some follow-up stuff on it. Hopefully I'll have all 10 fingers and both eyes without a patch, Jerry. And I don't need an eye patch. So we'll see what happens. But yeah, I'm going to play with this and have a lot of fun. It's kind of exciting, and it's better than I thought it would be. So we got a successful cut. You really can't see the SainSmart that's beside the wheel, but we got the word SainSmart. We got a nice, beautifully cut wheel. I learned a lot. Anyways, apologies for not having the CR30 stream on tonight like it was scheduled to do so. But some issues came up. We were having there was a few issues as far as breathing, because we're having forest fires out here in BC. There's something like 3,000 or 6,000 fires burning in British Columbia right now. And we're getting all the smoke. And today was the first day we actually step outside our house. You can smell smoke, and you've got very little visual distance because of the thick smoke that's covering the city right now. And it's just, when the forest fires rage up, especially with the heat we've been having up here, the unusual temperatures, those forest fires are brutal, and they start easy. And we get the west wind and we get the smoke here. And it's just, the forecast for the next week is smoky and hot, basically, is what it is. They don't say sunny because you can't see the sun through the smoke. So, and so there was just a few issues with the smoke. And so things didn't happen today like they were planned, but we're postponing that hopefully till next weekend. But keep an eye this week, and we'll post something letting you guys all know what's happening. So Until next week, thank you guys for watching. Liam, again, thank you for joining me and helping me out with this. I couldn't have done it without you, I guarantee that, because there was a few things here that I learned today. So thank you so much, and we'll talk to all you guys next week. Have a wonderful week until we see you next time. Bye-bye.